Hey, sorry about that. I actually had some technical difficulties. Right. Hmm. The bearded chicken is not yet in the game, but soon. All right. So, as a recap, here we are. All right. So, one thing I did was, of course, we're having seasons here: summer, autumn, winter. We need to put snow on top of these guys as well, and we need some snow and weather effects. But basically this is how seasons work now, and we do have quite a bit of stuff added to seasons. So if we go here, actually let's close others, close this guy. I was doing some coding before, so this isn't super well set up. Okay. Yeah, my microphone was refusing to work, so had to do some stuff. Anyway, we have this weather system. So every season has a sort of an hourly daytime stuff, an average temperature per day, and we also have, like, this is for the background color and the sky color that's gonna go into this light color thing. So throughout the day, both the sky and the light color change, right? So we have this kind of daily light data. Okay, nice, thank you. And yeah, this was a bunch of stuff I did. Also, we have here one of these systems, not this one. This one basically updates the temperature. So it is fairly complicated, and I plan to move this on the GPU because with bigger terrains, this runs per cell. I just plan first I need to get this temperature simulation stable, and then after that I will just kind of move it to the GPU. Although now that we have a nicer rendering engine, I can debug shaders, so it's not as bad to debug. But it's a bunch of complication happening in here. So yes, rain and snow will happen. They won't simulate water, so it's just kind of like a visual effect. Maybe rain would do something, so if you sit outside in the rain you get cooler and stuff, but they won't accumulate water in puddles and stuff like that. So that's not something I'm planning right now. Also, like, for atmospheric kind of reasons. Other than that, I think this looks fairly cool, and I have the art for the rest of the blocks. Maybe I need to figure out what to do with all of these things. So if these are outside, it's a bit, I guess they can stay like this, or I can add a bit of snow on top of them. Can't quite easily do that because of how this artwork is being done. If it were 3D, maybe it would be a bit easier, but yeah. Right, so today I was thinking maybe we won't work on this complicated systems that emit energy. There's a bunch of material data. So for example, if you dig, right, so you live here underground like this. Well, this isn't a good example, but basically there's a sort of a coefficient that there's for stone and one for earth blocks. Also, the dwarves are considered flesh blocks that have a different conduction index coefficient. So it's quite complicated. The thing is, it's not super stable, so I'm just gonna kind of ignore it for now. But there's this is a system I already had implemented, but I resuscitated for the purpose of this. Also, these are a bit, I think, a little bit big, these clumps of dirt and stuff. Right, but anyway, so if we do this, also I need to figure out how to hide what these things are. For now, it's useful for me to see the terrain generation works, but in the future we can just have these things like always transparent, so you know where to dig. Right, but today I'm thinking of doing some optimization work, because I want to have a bit of work done soon on terrain generation. Right now, terrains, we're not really generating proper terrains. I mean, there's a bit of purling noise, but they all honestly look the same. Like, they're kind of all on a top of a hill, and then there's this kind of fairly steep bottom of a hill. I don't know, maybe it's fine, but I wish some had more flat areas and then some steeper things going on. Also, this isn't super deep, so the way you'll play the game is supposed to be bigger than this, right? And right now we're kind of like, this rendering engine I have shoves everything in same buffer for everyone. So these are the buffers for instances, cold instances. There's going to be very few. It's the visible ones, so it's almost 0%. So for the GPU data, I never allocate, I just have everything in memory. Okay, always. So what are your thoughts to have terrain seeds the player can choose, possibly special better than anything? Oh, actually, this is exactly how terrain generation works. So everything is with a seed, right? If we go here, game RS, here, this is kind of a seed, a world seed. So we choose 3 words randomly from a word list. We generate the seed, which is some string, and then this world seed is sent into generating the terrain. And I think we do some, we transform it back into some hash, I think. I don't remember actually. Seed. Oh, I saw it. Sorry. Yeah. There's a seedable RNG from this seed. That probably is also used in. Sorry, I jumped. Anyway, it is like that because I also want to be able to. While a lot of random things will happen in the game, I want to be able to basically have a deterministic gameplay once I know the seed, so I can reproduce things. It actually makes a lot of stuff easier like that. So yeah. Another thing. Hey, all right. Coding time, coding Sunday. Some coding of your own, no problem. Right, what else have I done? Oh yeah, I fixed some. Oops, I closed the game accidentally. I fixed some bugs with selection. So there's a few things that bother me. So when we were selecting things, I had to. These dynamic objects weren't writing in the selection buffer. It's getting a bit cramped here every time I select, but basically, yes. Clicking these, if you weren't clicking the base of a cell, so basically on the terrain this thing was, so like here, if I was clicking here, I wouldn't select the workshop window. As you can see now, everything is fixed. One thing I still need to fix is when I'm clicking on these other tiles, they're basically children of oh, thank you for the prime pose. Berto, nice. You're actually feeding Twitch money because I haven't wrote my taxes there, so I'm not getting any of this. I'll but yeah, thank you. I'll have to sort that out somehow. It's always like this. Yes, so anyway, now selection works and these things are written to the selection buffer. The way selection works is actually quite neat and not too crazy. So let me show you with render doc. I'm not super happy with it, but it's not too bad. So we need one thing, working directory. Okay, so I'm gonna see a little bit about how rendering works here. We're capturing a frame. Right. So here we do some compute pass. In this compute pass, I figure out it's super inefficient, but basically it figures out right now it's supposed to figure out what's visible or not. Today it does nothing. So anyway, and that bit of code, that bit of data is then passed into the render pass. Actually, it does some stuff here in the compute pass, but I don't remember. I think we remove cells that are not supposed to render because they're outside of the screen, but they don't remove cells that are behind other cells. And we might get to that today. Anyway, in the render pass, we use draw indirect, and we render these things one chunk at a time. This is a chunk, so it's 16 by 16 by 16 cubes, right? That are drawn in a single draw call. And you can notice here some inefficiency already. So these are, this is almost a solid block. So it's almost 4,000, almost the max, but basically these are the number of instances. And the 36 is a cube with this many instances. And this is pointless because most of them are invisible, right? You only see the outside bits. What you normally do in isometric games like this, you'd create one mesh and stitch it together and not stitch the interior. So we might get there, but for now, because honestly for this type of a game, drawing is not too bad given how hardware looks today. Even an inefficient draw like this is super fast, right? So this is how the terrain chunks are being drawn out. Pretty cool. And then we draw one by one everything else. Right. So these are the dwarf pieces, the everything, pieces of furniture. Right. So we can see here some of these are already appearing. And now we can look at our picking texture. This isn't too useful unless I zoom out a bit. I restrict the, sorry, not zoom out, I restrict the range so we can see some colors here. Well, let's move back here. So which one is this one? This is a cube here, right? So this is the draw call. Okay, so we move here. And you see it here appearing. And this wasn't properly written to the picking texture before. And this texture, you can encode anything you want into it. For historical reasons, the way it used to work when I had OpenGL, I was writing the cell position here, encoded into RGB value. That then I bring back on the CPU, and based on where you click, I know exactly what position you had before. So I reconstruct it, just some bit shifting magic. And then I query my game for what is at that position. So basically, if you click here, I encode the position of this cell, and then it's a very fast query to get the items of a cell of a certain position. Items, as they move around, they write themselves to the terrain cells as I'm here. So it's kind of super fast. What I do want to improve in this space as well is writing the entity ID. So when you click on something, you get an entity ID, so you don't even have to query the terrain for what's at that position. Pretty cool stuff. Right. Okay. Now that this is out of the way, we will move on to what's being slow here. So there's a few things that I haven't really done a good job on. So this is a tiny world, 32 by 32 by, so it used to be what? 32 by 32 by 32. Right, and now it's let's go with a big boy world, right? This is debug again, so you know. Okay. Also, by the way, everything here is in a JSON, so we have weather data, right? So this would be the start hour, then end hour for summer. Don't remember what these are. Oh, this is for what kind of sky color. So these are all the hours in a day, I think. So for every hour we have, or like there's a few chunks. Yes, so exactly this black layer here is bedrock and it cannot be destroyed. The reason for that is you can do very well, actually. Anyway. Okay, so this camera is at the wrong distance, so we're gonna fix that first. Yeah, so there is a bedrock all the way down. The reason we have bedrock all the way down is because we have kind of fake physics with things falling down. So if you don't have that, you can just have a hole in your world. So you don't wanna do that. It's gonna also look wonky, but if it's some bedrock you can't ever break, that's perfectly fine. I think there is a distance somewhere, maybe not here, maybe in the other camera. Distance. Alright, so this is a bit, but you see, it's still kind of like a huge hill with a hole here. Actually, it's because the seed is the same. So, there's that. But anyway, it's not super fast. The reason it's not super fast is, there's a few reasons. But we'll whip up a profiler soon enough. Also, these are kinda wrong now and they're gonna be under terrain somehow. So I don't know how that ended up like this. Yeah, so this is under some terrain. Right, but it's kinda... so in release, this, even today, this isn't a problem. So this moves, it's gonna be super smooth in release. But because most of my time I spend in debug, we're gonna spend some time optimizing it today. So... terrain optimizations, part 15,000. Okay, wait. It's gonna be a bit of a painful thing for me, especially because Superluminal is not made to be used in tiny, crammed 1080p places. There's been already a bunch of optimization that we're gonna talk about as well. Okay. And I think one easy fix would be to treat terrain and my dynamic meshes differently. So we'll see exactly what I mean by that. It's so funny actually, by the way, Z on Windows somehow just has a new icon every day. I don't know what's happening in this nightly channel. Yesterday it was yellow, now it's a splotched gray. What's happening? So let's check. Let's check a few things here, right? So we have our mesh pool. And this mesh pool has data in it that we upload to the GPU. And then everything happens on the GPU. We don't touch it once it's uploaded, in the sense that we determine what's visible on the GPU, we move it into position. So the most important part of that data is this buffers, vertex buffer, index buffer. These aren't that important because, well, basically the terrain is, let me show you. All right, so chunks, this is 20 milliseconds. It's a lot, right? And somehow we're allocating random things here. I don't know why. Oh, maybe the inner vectors of the mesh pool. But yeah, create mesh resources is 26 milliseconds in debug, and then we write this buffer. It's not great. So this ends up being 64 milliseconds. This is 100. All right, so stuff is happening, and then I'll show you what is that stuff. So for terrain specifically, which is this chunk bit here, and then there's this like other 100. Sorry. Commit upload. This 1 millisecond is everything else, which is kind of high, but whatever. It's just a bunch of dwarves and all of that stuff. But the terrain, I don't know how to move this thing. The terrain is a lot. Create mesh resources for the terrain, right? So what happens in here, we have instance buffer that we always reset. So even though the terrain doesn't change, we always re-upload all of the buffers, which is not great, right? And we briefly discussed this, but I didn't end up implementing it. Create mesh resources, right? So you see here in create mesh resources, this is a chunk, and what it would do most of the times, it will go here, which will add the mesh I just saved back into that array every time, and that will be basically a block with 4,000 instances and some data about it. I don't remember what this is used for, but I think we added two different buffers if they're opaque or not. I was thinking, don't quite like this. Okay. And then if the terrain changes somehow, we recreate everything here. So we look at everything, and from the instance data we create the whole array of instances, which is a lot of work. Okay. So what I would like to do is maybe not upload this at all. And again, one thing, this is debug, right? So in release it's just fine, but add mesh pool allocates. So this isn't great, but then there's a bunch of tiny, don't even know, tiny allocations are there. In add mesh. So if I click on this one and we look at the breakdown, yes. By the way, before I actually did some more stuff. Thank you for mentioning it. This arena stuff works great in the end. So this mesh data takes an allocator that is pre-allocating and is just like a bump allocator that this vector is created in. So basically all of these allocations here are kind of never going to the OS. And I didn't, well, that's fairly useful, but I didn't do it for the terrain because I want to save this terrain data. But then an even nicer thing would be to never re-upload this data unless it's super necessary. So this is the 100 millisecond one. I think this is because we're recomputing here all of the matrices. Like there's a lot of from scale, rotation, whatever. Build textures. And a bunch of random stuff. So let me go to another one. So here. Add mesh. Mesh pool add mesh grows a buffer that creates a mem copy. And this is because instance data. Oh, it's because I can tell you why. Wait. So let's go to our mesh pool. One thing I did here is these buffers we add meshes into. It doesn't say which one it is, does it? Just that it's a dynamic buffer of instance data. Okay. Yes, so these buffers are of dynamic buffer of something, right? This is a type I created that basically has a WGPU buffer. So this is kind of an ID. A buffer size, because I pre-allocated, so I need to kind of know the size later on. Offset count, to know how much I've written into it. So yeah, new data starts from screen, and we have this kind of scratch buffer idea, which is basically a vector on the CPU that all of the data goes into, and when you say update buffer, no, sorry, add. When you add to your buffer, you add to the scratch buffer, and there's this commit upload that actually use this write on the GPU. The main copy is word aligned. Some architecture start on this. It might not be, but we will skip that altogether. So we'll see how in a second. Because the reason I have the scratch buffer here is I write into it and then I upload it to the GPU, right? And the mem copy is basically this guy growing, right? It's actually surprising to me somehow that I thought so. Like, why does this guy grow when we clear it at the end of the commit. Like, I think clear shouldn't... Yeah, this method has no effect on the allocated capacity of the vector. So this is frame number 1 billion. So I thought by now this is in the middle of the game literally. So I thought by now it would get to the maximum number of instances, especially for stuff like terrain. So this is a bit surprising to me. It's very surprising actually. Because I thought clear just leaves the memory there. Oh, it's not that. Right, it's not a grow. It's a mem copy, it's not an alloc. It's this function that takes the list of instances and puts it here. But anyway, it's basically a long story to say all of these things that happen here are kind of honestly pointless for terrain. So force the engine to run for a few hundred milliseconds, simulate some junk gameplay. Start. Oh yeah, but we did that. So this is like in the middle of things. Yes. There's some UI stuff. Yeah. Anyway, that's all of this is to say we're doing silly things that are useless. So I'm thinking now I should never... There is a problem that's preventing me from easily fixing all of this, which is we're using the same buffers for terrain and for objects that move around the world, and this brings a little bit of problems. Now let me check what we do in the chunk, because I don't want to build an allocator. Long story short, I just want to not have to deal with that. So for each cell in my cells, I was a chunk. I never skip them, right? So this might actually be air cells. Could they be air cells? I need to remember actually. Yes. We did this is the thing, we did a pooling for this other guys in dynamic meshes when we create them. I guess, well, the thing is, it doesn't quite matter what's happening because this is a mem copy. This is not an alloc. So actually what this is really is when we call add mesh, where is it? This is the optimal value actually. So when we call add mesh, we will call it with 1 billion instances that then the mesh pool copies into the scratch buffer for instance data here somewhere. Yeah, for the instance buffer. And this is what we're seeing. This extend from slice will be a mem copy of this array into this array, right? So that's not good. So what we would want to do is make sure we never do this unless it's absolutely necessary. So the way memory works is in the beginning of my buffers, because they're all shared, we will have terrain data for all of the chunks and then dynamic stuff. So this is kind of how it looks like, dynamic stuff right after, and this is terrain. So there's a few trickeries here. This route now works because every time we re-upload everything into those scratch buffers and then they go on the GPU, everyone's happy. If I stop re-uploading every frame, which is what I want to do, we need to make sure we keep some indices around correctly, like this guy here. Let's say where the dynamic stuff can start. In here. Right? Some offsets. And then when I can then modify the terrain data when things get modified. I always want to re-upload this for now because entities get created, they get destroyed, order matters here, so there's a few trickeries. But for this one, we can just shove it all there and then modify a cell here and there whenever it changes, right? So let's see how we would do that. We need a way to update this guy, which I think I have. Dynamic buffer. Right, subdate, upload, updates GPU data, winnie values, doesn't use scratch buffer. Right, this is the problem, because, yeah. And this just writes from a buffer offset this new data. Okay. Which is fine, because this is an operation that will happen rarely. So for now, let's stop re-uploading the terrain. Okay. And we can go here. And instead of calling add mesh, we do nothing. And instead of holding the mesh data, I want to hold the, what is it called when you call add mesh? What do you get? You get back a mesh draw data, which is kind of like a bunch of IDs and stuff, so way smaller. Yes, it's just hacks upon hacks, basically. What don't you like? Oh, it doesn't matter what isn't its option. Also, like, this is not an engine, right? So we're building things as we need them, and we need them now. And mesh draw data will be, we skip this guy, right? So before this, we will be like if let sum whoops. Well, actually, I didn't. If let Just skip it. Gentle suggestion, paraphrase the questions as for both Twitch and YouTube. Not the content. This is a great suggestion. I'm gonna try to do it. Because I keep forgetting my chats are not on the stream somehow. I should do that. Okay, so actually, okay, let's do this. So for now, what we need to do is to upload this data and never have to re-upload it. So there's a few things that need to happen. You know what? Before we do that, I need to do something because we're gonna have a bad time. Mesh pool. So here's the thing. Resetting shouldn't move my offsets. Wow, this is gonna be ugly. So this is the thing, resetting these buffers we need to skip this, so these are always on the GPU. Oh, actually, do we need? Do we need to do this? Offset count is 0. And this, I guess, brings back this offset in the beginning. Not good, to say the least. We should reset it to dynamic object start. Or we should use 2 different buffers, which both things work. If I use 2 different buffers, though, I need another render pass, so I will just then last ID. Whoa. Okay, so let's not do this. Let me think for a bit what would be easier. I think it would be easier to have these buffers separate from between static and dynamic things. But it's so convenient having one single buffer for everything. Okay, let's make a static buffer. Static objects buffer, something like that. First of all, let's rename all of these. Materials don't matter because they're never, they're always gonna be in memory. Bounding spheres for dynamic, instance buffer, called instances for dynamic. I think these two though, they need to be, do I need two mesh pools? Would that be easier? This don't, right? This is another. Oh, this is gonna be pain. I don't like it. Let's make another struct. So we're gonna have these guys here, bounding spheres here, called instances. This is the output, of course. This as well. I don't remember actually. Why do I have this and this? Oh, because from the instance buffer, this is the output, and then from the draw command, this is the output draw command. Okay. Compute buying group is fine, and overlay. Do I need this everywhere? Yes, I do. I think this is it. Why pub? No, don't look at this thing. Or maybe I need it in rendering later, so whatever. It's fine, but I think this is, I want to see what we do with this buffer, because this is dodgy a little bit. Commit upload. Where is this? All right, so let's call it correctly transparent. And actually these cheat a little bit, I think, because they get drawn anyway, they don't go through culling. So maybe the transparent geometry data should be its own thing. And then do I ever write to this actually? Oh, what was it called? Overlay. I need to check. Maybe we never use it. Problem solved. We're gonna panic here. And then I think transparent things can have their own geometry stuff, because like what's going on here, right? This does mean a few things that are a little bit annoying now. Let me think. So there's a few advantages and disadvantages to this approach to have geometry data, and I can have pub static. Right? Something like that. And this is someone said love the synthwave background music. It's actually this classic synthwave radio. You're actually on point with the characterization, with the category. Okay. Another thing we can do is waste a bit of memory and start our dynamic objects at an offset and just call it a day. And then every terrain chunk will write the maximum it would need, and then just update that geometry. You know, let's do that. Great. Get stash. I'm actually no. Not super convinced. Great idea. Okay, let's do this. Because maybe we'll have here a transparent thing as well. That would be basically stack allocation, more or less. And we can use these buffers as bump allocators more. The problem is mixing them. It means resetting becomes tricky because you need to reset them right after all of the static geometry. So you need, when you add some geometry, to know if it's static or dynamic, and you're not allowed to interleave the way you add things. So, and then I can see a little bit of hell where every one of these buffers will have a different kind of value, but they need to hold an offset to know where the dynamic data begins. And reset would reset it back to that offset, so you can do that. And then you don't need to change the pipeline, and then you have just one pipeline that does culling in a compute shader for everything, and then we draw things in the right order, and then we draw transparent things at the end. I just don't think it's worth dealing with the pain of maintaining those offsets correctly. Also, imagine we create terrain. So if we look at render doc for a second, you'll see why I'm hesitant. I think I have a build that works. Okay. So if we launch this guy, it might sound easy, right? Because you're like, well, just, you know, save the index. The problem with that is just today we don't have the maximum number of data per chunk saved in these things. We can change that actually. So let me show you what I mean by that. So here in the compute we can't see anything anyway, but in the render pass, this wait, let me check if this is visible. Yeah, so this render 4096 instances, which is the maximum, is 16 by 16 by 16. Because they're full solid blocks, they're not visible. We don't do the culling, it's fine. I'm waiting for one that is visible, so it's gonna be a bit easier for us. Whoops, okay. So you see this chunk had only 4100. What? Oh, actually, yeah, it's a bit more than 4096 because we had some extra grass on top here. And they go into these instances separately from the grass is something that's put on top of the dirt block. But anyway, let's say we get to a magic number that is this plus grass everywhere or plus whatever offsets. You'll see the later on ones. Maybe this one, yeah. This tiny guy has only 700 instances. These are the instances. I actually need to bring this more into the view. So this has 700 instances, whereas the next one is so basically I can't ever create, like if I keep these like this, I can't create things here in this chunk. Because there's no space to add those instances. What do I do? Do I put them at the end? I could do that, but then it messes with my layout. So it messes with my layout anyway, thinking about it now. So I can just pre-allocate the maximum here, and then they're all gonna sit in memory doing nothing. They're not that big anyway in terms of data. But I just don't like the idea of every one of these array having a separate ID, which is where dynamic objects start. I just don't like it. So therefore we're gonna go with this approach. Alright, so let's get this code to compile again. Oh, let's also implement reset. This is the transparent one. copy it back here. We don't support transparent anymore. Update mesh instances. So this would be the new instance data for this mesh. Okay. Oh, this goes into the why is this repr C? Do this go on the GPU? I wonder. Maybe this is something we don't wanna. Can I do this? I need to grab some water. Give me a second. All right, I'm back. Right, so where was I? Okay, what's wrong with this guy? Only available for structs. I think well, which one was available? Oh, I can't do this. Do I need to manually implement this? Well. No, not you. something we just need here. And is this now working? Yes. We're not gonna mess about with these things. Okay, maybe don't touch it for now. I don't think I uploaded to the GPU at all. Okay, and now how do we do these things? Okay. Oops. Okay. We need to move all of these buffers. Now, are these sizes crazy? So maybe we can also adjust them a little bit. Materials are separate instance, bounding spheres, cold instances, input, output. Can I put them by? Nice. Oh, we need a device. Okay. Because this allocates the buffers on the GPU as well. No problem. Let's not touch this. Turns out we need a compute buying group as well. Good. Okay. Compute buying group basically is needed because it describes how we're binding these buffers and where. Buffer binding. This is some magic here. We're having some offsets, but we're binding the whole thing. Static geometry is geometry data, and then this is not needed anymore. Okay. Wait. Okay. Commit upload. Oh, this is a future me note, basically. Oh, come on, man. Okay. Okay, whatever. Static geometry, commit upload. I don't think. Honestly, I should have just copied this mesh pool, but I guess it's that material stuff is common for both of them, so it's fine. Where is it in use? Okay. This will be moved into the geometry data. And this is the other buffer we don't use. Commit upload never found for this. Don't think we need it. This is not needed anymore because this was the transparent bit. Stats will be per geometry data. Actually, let's do the other way around. Because this is already exposed, so if I go in here, where is this? Oh, it's in render context. Let's do this. I really thought I could reuse more of that mesh pool for both things, but they need the buying groups, they need everything. So now I can just do static mesh. Or dynamic mesh, right? Whoops. So Because actually, even the transparency thing, hack thing, it's basically, it could be static or dynamic. Let's say you build a cube that's made of glass, or like a window, yeah, a cube made, or water is a better example. Let's say this would be with water here. It would still go into the static buffer. There's no need to re-upload that water all the time. Even if it would be modified by shaders and stuff, but like, yeah. So therefore, this is a better idea. Okay, now we have these two things. Add static mesh, add dynamic mesh. We can wiggle this somehow. And then when we draw, where do we draw? It's here somewhere, no? Yeah. Oh, this is an ugly. You shouldn't touch these by hand. Okay. This would be the correct way though. We already reset the dynamic one here. And I think here in terrain, add static mesh. Add static mesh. Actually, this is way better because now we'll get something working faster. There's still some errors here. Right, so geometry and texture bind group, vertex buffer. And then we do a render pass with a mesh pool. Okay. So this needs to change. So render pass, bind groups. So when we render with WGP, rebuild mesh pool, this is fine. Compute pass. What? How does this not require any? We have a texture pool. This is the texture for everything. Okay. Oh, this is the encoder, and then I can create two compute passes, or I can shove them both in here. Let me see. So here, right. Geometry and textures bind group. I don't remember how rendering works. So draw instanced. Take this bind group as a parameter. So we have a compute pass with this mesh pool, and then we render pass with the mesh pool. So basically, the only thing is this entry here confuses me. Why is my vertex buffer required for this guy? Oh, and the bind group comes here for compute. Geometry and textures is here created. And this is the texture we read from, and this is, I guess, the vertices. Okay, so one thing is I would want to move these inside of the mesh pool then. Because otherwise it complicates my life. And this is actually literally, we render here. So if we do compute, render, I can add it to actually the same compute pass and then the same render pass separately. Alright, but this guy needs to go, so... it's because of this texture. Buffer binding. Okay. What if we do a method here? Is it? I don't know what that is though. And this would return a bind group. And then something like this. And I can return this guy. This is actually renderer, maybe device is even better. Wait, there's a few things that I need to clean up here. So we have the render context that holds both the renderer and the mesh pool. So maybe render context should have this method. Instead. Render context will take the mesh pool and the renderer. Yeah, okay. Cool. Also, this buying group, we can cache it here because I think it's always the same thing, right? So once we have all of these bindings, we're good to go. And the texture will be... Please tell me we have a texture pool here. We don't have the texture pool in... that's annoying. I should move it inside of this, but for now... For now it's fine. And this is at mute. Whoa, okay. Mutable? Why? I don't think it's needed here now. This is a hack. Found nothing because this should be returned. Okay, now that I have this guy, nice. We need some cleanup, but okay, actually a bit of a crazy cleanup time. This is gonna be here, this is fine. Okay. This will become a function on the mesh pool. Or maybe that's why that was moved. Okay, cool. It's to please the borrow checker guy. That's fine. And then it's because this is a function and then complaints happen. Oh, sorry. So then this should work, right? First of all, apparently I was blind. Texture pool exists here, so This doesn't need to be like this. Fairly sure we need to write to that texture pour at some point, but yeah. Let's get this thing to compile now. Okay, game UI. Okay. Okay. We'll fix this later. Compiled? What? Okay, it's good. Oh, I think it's because... Did I remove the reset? Yeah, I removed the reset on the other one and we keep adding things to it. Which is not fantastic. How should I do this? Let's make everything in the dynamic mesh pool then. And then I'll move the other stuff out. So this resets. This creates mesh resources where in static meshes, right? So instead of doing this, we should do the following here. Oh, mesh data, what was this? How should I do this? Just skip it for now. And then we build up the mesh data here. Whatever, and then well, then we do this. And I think this can be on an else branch here, and then if we do have it, we can update it with new instances if we need that. So this goes like this. We don't need this. If There is a sort of a needs update. If we don't need it, return. All is up to date with this mesh. If not, we create stuff. Well, okay. Right. We need to figure out some if statements here. What's wrong here? Oh, this isn't closed. Okay. We add these instances. We save them here as well. This is the old legacy whatever cache. We don't care about that. Oh, right. This is right. These instances. This mesh. This mesh needs to be here. Oh, we already had an update mesh instances. Okay. And from this mesh data, I can figure that out, but okay, let's go here. What do we have? Rebuild mesh pool. What is this? Instance data. And then, whoops. Oh, I changed this to be static. Update mesh instance and can stay like this. To do. Right. Because this has a bunch of IDs inside, like material, first instance, whatever. And I think, yes, this won't work. Where do these instances come from? We have them here. I guess I could remove this. And then this is not in an if else anymore. And then the if will be here. Okay. I think this is part of this comment is old. Okay, and then we don't need this because we have it here. Okay. So we should see this happen once. This doesn't need to be here. Nice. Somehow nice. The problem now is here when we render things, we don't render them, so yes, invisible fog, that's just the new weather effect. Yes, we optimized everything, it's super smooth, but we're rendering only the background color. Yeah, in software there's always trade-offs, that's the thing. Add indirect commands. Okay. Static mesh pool. Oh no. What does reset do here? I think I don't super like this. Why do we do this? Always. If scratch buffer is empty, return. Okay, maybe we can clear the scratch buffer and return. To be honest, this is called dynamic buffer, so. And then scratch buffer, bloop, and then clear. Actually, yeah, it's gonna be fine. It's gonna be fine. Now we should have the data on the GPU as well. Just trying things out, because I'm not really good with... Right, so this is my terrain. Okay. It's blazingly fast, but... we need to go back and put this other big boy world here. And you saw we don't render dynamic objects because we didn't do that yet. But let's, you know, let's see if the big one is faster. See what the vibes are here. Boom. Okay. Generation of terrain also takes quite a while. Oh yeah, boy, these are so smooth. This is so buttery smooth. Optimization, baby. Yeah, this is super nice. I'm actually very happy. So with all of the inefficiency we have in rendering still, by drawing 4,000 instances per chunk, this is, I don't know if you can tell, I don't have an FPS counter, but I promise you this is very smooth. I love it. And then let's launch it if we don't believe. Save the cat. Oh, don't. Sorry, this is a render doc. I'm in the wrong tool. Let's run again in the debugger, right? In the, yeah, with debug in the profiler. Man, this is so nice. We can also optimize terrain generation. The reason it's slow now, it goes through all of the terrain cells and decides if some of them needs to be changed. So we put some diamonds or whatever there. Okay, this is obviously a bit slower because we're capturing stuff. Whoop. I have a tiny snack. Nothing. 11 milliseconds. Yeah, 60 FPS on debug with a massive world. And this is just waiting for swap buffers. Ah, so cool. All right, so let's see what happened here. Update mesh pool, update mesh data. Does nothing now, you know. So of course it's fast. There's like a random cube being created here. I think this is the dynamic stuff. But anyway, it went from 100 milliseconds, or in other cases, what was it here? So this is with swap buffers, okay. Here it's like 30 FPS when and a good, but it was like 26 milliseconds. Oh, 68 milliseconds per frame, so it's complete junk. It went from that to, so from the end of this to the end of this, 14 milliseconds. Right, so 16, basically 60 FPS. Most of it spent waiting and a bunch of stuff, right? Okay, but as you may notice, this game is called Dwarf World, but there's no dwarfs now because we don't render the dwarfs, the dynamic objects. Okay. So that needs to be fixed. That is simple to fix. So here we have this magical thing happening, which is called rendering. Draw transparent. I don't get it this one though, but okay. It is the world previously inhabited by dwarves. Yeah, it's indeed. I didn't say the dwarves are still here. That's like a separate DLC you have to buy. Yes. Oh, here's the thing that I think will come back to bite me in the ass. Here is end rendering, but look at this guy, transparent items. So in the future, foreshadowing, now we have transparent items shoved both into the static geometry and the dynamic geometry. But then this means I'll have some random transparent objects drawn in the middle of static, 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 transparent, 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 dynamic, 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 transparent. These guys here are not supposed to be here. They're supposed to be here for things to look proper, I think. Yes. Is that true? Actually, let me think. Is this true? Is it true that I need... Yes, it is true. Because if this dynamic object is behind one of these static transparent objects, it will not look as it's supposed to. That's why these guys need to be pushed here. Now this isn't a problem because all of the terrain is not transparent at all. But just so you know. Alright, so how do we do this? Mesh pool. I think I could just do a 4. Would this be working? And then we issue 1 compute and 1 render. No. Wait. Okay. How does the compute shader visible stuff? Wait. It's something unclear in my head now, which is how do I get data from compute? From the compute shader that figures out what's visible to the draw pass, to the render pass. That needs to be somehow passed around. Output, okay, view, compute pass encoder. Compute, whoa, compute buying group. Oh, this is in the mesh pool. And then there's this other buying group. Which is also from a mesh pool. That's just the static one. So I could parameterize this Okay. This doesn't need to be a function here. And it can depend on what's this data structure? Right. Rebuild mesh pool, render pass, blah blah blah. Geometry textures buying group, okay. And it will be, I need the render context for a bit. It's just texture pool, okay. Wow. It's not a WGP thing. Okay, there's the texture pool I need. The device. Put the device first, it's nicer. Okay. And then texture pool like that. And then the mesh pool. And layout. Is buying group layout, okay. We don't need it like this. We need only a reference. The device buying group layout, the texture pool, which for some reason is being picky about things. Okay, fine. Okay. This is never used. Of the device. What else do I have here? Buying group layout, texture, okay. Feel like I felt it. I felt this guy being included. Then it need to be okay. What I'm doing now is I'm preparing this chunk of code to work with two mesh pools, so it's a bit easier. Okay, that was a weird error. Okay. Terrain generation, the next frontier to optimize, but for now it's fine. I don't care that much. Okay, everything is in place. And I think we're done here because this is all parameterized on the mesh pool. So what we can do, it's look at this. Okay. What? Oh, thank you, Vim. No problem. This is it. We first draw all the static stuff and then the dynamic stuff. I say confidently, and now that we run, let's see. Please work. It worked. Blazingly fast. Nice. I mean, obviously there's the bugs with what's happening here. Why do I have... Oh, okay. There's a few visualization issues. I can't tell here where the terrain ends, so that needs to improve in the rendering space. So we need to kind of darken these edges so you know when one level ends and the next one begins. Once we add shadows and a few other things, and there's like this other thing where we have stuff going through terrain. That's obviously a bug, but they just spawn and fix position, so they happen to be underground. Okay, but like now we have all of this world, all of this hill to play with, and I'm fairly sure if I add more, it's gonna be fine, right? Oh, I should have... One thing we need to do is the buffers. You see some hints about the future. I want to add PBR factors. I want to add some nicer lighting and stuff. That's for physically based rendering. That was removed, so now we just use textures. Oh, these don't have an ID per se, they just are material IDs. They just are indices in those arrays, but they don't say where from they come. So actually, you know what, this never gets sent to any GPU, so this is nonsense. So I can just do here a kind. Easy peasy. And load macro for enums needs to be... This is a mega hack for my save load system. Come on. No, fuck. Whoops. This is a thing we don't need, actually. Okay. And this kind needs to be set somewhere, right? So how do we set it? Is gonna be okay. Oh, this isn't like in Visual Studio. We can do it here and then initialize it in the beginning. What? New, and then this is the render, and then we mesh kind, and then shove it in here. I think this is all we need. What's it called? It's called just kind. Okay, there's some other place where these are created. I need to pass a parameter. Oh, they're in here? What? Seriously? Oh, this is not public enough. Right, and now oh, my editor is dying. Don't worry about that. Okay. I could maybe, in case I add more types, even though I don't see why. Should I just kind of, you know, yes. Beautiful. I think this is the error it complained before. We are good now. Yes. Ready for shipping. This is the thing with optimization. You don't need to... There is a little bit of truth in not doing everything at the start, but I think it's really important that your engine is easily optimizable, or whatever you have, piece of code. Because this is easily optimizable, literally. We went for 100 milliseconds per frame to 0, but the reason this worked is not because we were like, oh, let's not do premature optimization, and then we wrote completely crazy code. The reason it worked is because I had it organized fairly decently. It was quite well organized piece of code, so that's why it worked. So, you know, you don't need to do optimization, but you still kind of need to design code for it being easy to optimize later. I think is the thing usually newbies miss. Is it digging? Oh, okay. One thing with this whole thing is this guy is digging, but the mesh pool, as we can see, isn't updating. Why? Good question. The reason it's not updating is because instance data upload is never set. And I believe here maybe we can try. This is not gonna be super great. There is no way. Also ensure I have a nice green field. Later will be less impressive gains. Yeah, that's true. That's true. But I could have designed this to be total spaghetti, and then it somehow you can get code that's just literally unoptimizable without throwing it out. Here's the problem. You know what I mean? So for example, I used the mesh pool. There was a lot of stuff we had scaffolded here. Then there's code that's really easy to optimize sometimes. This, I think, just keeping things simple like this helps, even if you don't optimize it from the start. Things are always just arrays. I don't mix GPU data with in-game data. Okay. Okay. Let's see. Okay, and things get destroyed as we expect them to be. Well, I think there's a problem now that I think this bit here means... Yeah, definitely. Didn't mean dismissively. Good structure is key to the ability to... Yeah, that's what I think, and I don't want people to get the wrong idea by seeing that, oh, this was slow, and then it got fast. It got fast because it was kind of well prepared to become fast. The problem now is we made it slow again because I believe this method here, we take cells to be mutable for many other reasons, nothing to do with geometry. I think even to update their temperature, and this will invalidate the cell geometry. So this piece of one line here, while it fixes a bug, it undid all of the other optimization. So what we need next time, while I fix it during the week, is a way to know that this terrain has been modified in such a way that it requires the geometry to be updated. But that's something to be done, because this just takes a cell and mutates it, but in a cell I have like so much data, and basically only if a cell is destroyed or created somewhere I need to do this. But right now I have no way to hook this into the terrain. But that's fine, we'll do this next week. Until then, I'm gonna stop streaming now. This was fun. We optimized a bit, and then this week I'm gonna work on actually, maybe I'll show you first. I bought huge amounts of things on each in terms of UI packs. So we're gonna maybe do some UI about these things. So I want to really start doing some nicer UI, but we'll see if this is gonna happen this week or next week or when. Anyway, It's getting late here, so have a nice evening.